Alright, what's up guys? It is Expert here, and today is going to be much more easier video for me because we're going external. Now external is probably the most easiest way of game hacking, and I suggest it for beginner usage. And if you don't know how to create the basic template, now remember this, if you use this online or in any kind of game that goes online and use this online, you will get banned. Because what it does is it opens handles to not only the game process, but it opens a handle to the game's window. So technically you have two handles that's connected to the game, and since you have two handles that's connected to the game, any anti-cheat can just scan the game for any other handles that opens up to it, and if it sees that a handle is open to it, it inspects the handle, see what it does, and if it modifies the game's code in any way, it will shut down that handle, or it will kick you out the game. Either way, not a good thing you want to do. If you want to do a bypass, I suggest you learn how to develop a kernel driver so you can allocate that memory and change the memory within kernel space. So first, let's get started with the files we're going to need. We're going to add, actually let's go into properties. I suggest you keep it to Unicode for now. We're just going to keep it at Unicode so we don't have to deal with all those pesky errors between multi-byte and Unicode. So we're just going to stick with Unicode, and we're going to create our first file. We're going to name this... We're going to name this... we're just going to call this main, actually no, external entry.cpp. We don't need no header files for this. This is just simple. This does not grab any module bases. If you want a tutorial on grabbing module base, we'll do that at another time, but this is just to benefit and learn from this. So first we're going to do include IO stream. Great. Give me a second. Include IO stream. Next, we're going to do include windows.h, and we're just going to use namespace standard to get this done with faster. Alright, so first we're going to declare our function. Now this is our main function. We're just going to add a few things up here, but not now. Actually, we might as well do that right now. We're just going to do huend handle window. Now, HWND equals handle window. It generates a handle to the window. It's pretty simple. We're going to have to initialize this variable, or else it probably won't compile. And we're going to create a handle to the process, and we're going to name this hproc. So we have two handles, and we're going to set the default PID. So when it gets the process ID, it will just go for the default process ID. So first function, we're going to use find window A, handle window, and oh, this is the wrong one. Wait a minute. I'm sorry guys, I forgot. You have to do this real quick. So we're gonna get out of here real quick. Now, don't mind the desktop. Let's just don't worry about it. We're gonna create a new text file. We're gonna name this practice.txt. Now let's open that up. We're gonna name don't mind anything in here. Let's save that. Now we're gonna take this here, practice.txt-notepad. So we're gonna go to oh my god, I can't spell today. Practice.txt.notepad. Make sure it's the exact same as the window. Notepad. Okay. And the parameters is asking for class name. I don't know. Okay. So this is the class name, notepad.exe, and the Windows name is practice.txt, as you see right here. Now we're just gonna do proc name, win name, oh, it's lpcstr. Okay. So we're not using wchars. That's good. We don't need this then. Okay, so now this will be hwnd equals find window a, because find window a is a handle to the window. Now we're gonna create a handle to practice.txt and under the class name notepad.exe. So we're just gonna do error checking if hwnd. Then we can move on. Get Windows thread ID. We want the thread ID. Okay, so we're gonna name this hwnd, and we're just gonna do at PID. So the address for the PID will be null. So once we get that from the window, it's just gonna take the process ID. We won't have to worry about that. Now we can do if this is a handle, isn't it? Okay, wait, now we can do if PID is not equal to null, which is the default process ID, then we can set our error checking here as, since we're going external, let's just make it quick. We can do could not find window, and here we'll just do could not get default process ID. Now we're done with that. Now we'll go into here. We're gonna actually name this hproc equals open process, and the process will be process underscore all underscore access. We don't want to inherit anything, and the process ID is there. Now we're gonna do if hproc. Then the error checking here will be could not get access to process. Okay, now let's go over it. We start off here. We created the variables here. So once it declares that handle window is find window A, and if we are in handle window and it's functioning correctly, then it's going to move on. If not, it's going to say could not find the window, and right here we get the Windows thread process ID from the handle window, which is here. And since the handle window defines this and that, it's just going to get the process ID for that, and it's going to turn that into the address for PID. And if PID is not equal to the default address of the process, then it's going to say could not get access, or default process ID. And if we get this here, this should already be all we should worry about here is getting the process all access. If we don't get that process all access, it's going to say could not get access. So it's simple as that. Now we're going to create memory. We're going to call this DWORD base address equals 0x. Now we're just going to close that there. We're not done with it. Just put 0x0. And we're going to do int RW, which stands for read value. Alright, we're going to set that to 0, and we're going to do write value. and this will equal to 1337. Okay, so let's go into practice.txt. Now we're going to open up Cheat Engine. We're going to open up practice.txt. Now when we're in here, let's just search for a random value. We don't want a value that's too high because these hex addresses are actually very, very high. So let's just copy this. Alright, so now we're going to back out of it all. We're going to set the base address to that address we just pulled. And since this is a 64-bit process, we're going to go into Configuration Manager, turn this to x64, turn this into release x64. So everything should still be functioning here. Yeah, there's nothing that was really harsh in changes. So now we're going to do a while statement. Then in this while statement, we're going to do get sync key state. That's my favorite command. We're going to do vk underscore f12. And then read process memory. We're going to do hproc because that's the handle to the process. Byte. And we're gonna read base address. We're going to turn it into the address of read value, and the size of read value equals null pointer. Alright, so let's go over this. After we get into the process, it's going to have this while code. So this here, all the code that I'm about to put within these brackets are not going to work unless we click virtual key underscore F12. You could change it to whatever you want. Next, we're going to do, let's not waste time. We're going to do write process memory. Now here, we're going to change this to write value. Write value. So what this does, it turns the value that's in base address and it reads it and it turns it into this. So here's the second option. We can either do RV, okay, write value, and turn that into read value and turn that into write value, or we can just stick with base address because we've already read the memory. But just for the sake of it, I'm actually just going to do both. So read value. Okay, so we're good with that. Now we see this hex is actually, I think, about 16 characters. I'm not too sure. I'm not too lazy to read it, and it's definitely a long. So it's, yeah, it is a 64-bit character. We're gonna have to turn this into DWORD 64, okay? Because actually, let's just do this without DWORD 64 to show you why I'm suggesting this. And to check that the code is working, we're gonna do message box and then null because we don't want it to shut down the code within the handle. And we're gonna do, I think, yeah, value has been changed, and this will be success, and we're gonna turn that to null. Alright, let's build this. Actually, this is it's giving me OCD. Let's change it. Okay, that looks much better. Let's build the solution. Alright, so it's successful. Now let's go into Notepad and open this up. So actually first let's turn this on. So the code's running here. Oh, it could not find the window, so we already have an error here. Time to debug. Let's see what was the problem here. Practice.txt -notepad. Notepad.exe. Alright, hold on. Give me one quick second here. Yeah, give me one quick second here. Give me one little second. Okay, so I had an error that I forgot here. This wasn't even required. I was wondering what was the problem here, and it shouldn't have been a problem. Now, I didn't know that this was actually a null value, which it was supposed to be, so let's actually recompile. Let's run the debugger again. This should work perfectly. Alright, so, yep, it's working. Let's go into cheat engine. Now, first, if you press F12, right? Hold on. If you press F12, it's not going to change. Now, the reason why it's not changing is we see our value here. DWORD, okay, DWORD is literally made for 32-bit addresses, which is 4 bytes in total. But the problem here is that, as though it says that in 4 bytes, this is definitely 12. But when we go into 8 bytes, it also says it's 12. So that's probably the highest operator we're going to go with, because if you go to float, it's already not what we're looking for, and besides, float is the actual number, so it has decimals in it. So since it's an 8-bit value, we actually have to turn DWORD base address into DWORD 64. Now that's going to turn into a 64-bit address, and if we run it again, let's pull up cheat engine. If we press F12 and we go into cheat engine, as you see, the value was 12, now it is 1337. Now let's see this again. I'm going to change the value to 12 now. So the value is 12, and if you press F12 in notepad, okay, remember the value is 12. Now the value is 1337. If we look here, the right value was 1337. So yes, we are inside the process externally. We can edit all the memory we want here. Let's just go do another memory. We can go for these seem like float values, to be honest, or they probably are 8-bit. Let's check them out regardless. Okay, yeah, these are 8-bit values. So let's try to throw this one in here. Hopefully we are successful. No guarantees. Let's go here. We'll change that to that address. We're going to shut down this command. We're going to run it again. Okay. Now hopefully this works. Oh, and it does work. So, yep, the values was 12. Now it's 1337. And again, let's just do it one more time. We'll change this to 90. And if we press F12, it'll change it to 1337. And we are connected to that process because we are using the window practice.txt. And that's exactly what we define here. So yeah, that's how you go into the process. Externally, I think externally is really good for doing quick coding. You don't have to keep on injecting, uninjecting. You have problems with your injector for DLL, but I think DLL is more efficient because you can get in the process. Like, you don't have to define stuff like this. You see how we had to define the window? There's a function here called get current. Actually, no, it's get foreground window, or it is get active window. So it's one of those two you use. Foreground is when there's multiple layers for the application. So say there's a startup for the application and then the actual application runs, then you would use get foreground. But if it just starts up as one application like this, because this here is a one startup application. So right here, it just starts up the code. This is it. Now this would be get active window. But if we had like a window that runs code for another window, then we'd use get foreground. But yeah, regardless, using find window A, we're getting the thread process ID. We're getting the PID as well from the handle that we've made to the window. We're reading the memory, we're writing the memory, and then this was to confirm that the memory write was a success. And we had to turn this from a DWORD to DWORD 64, because remember, this is not a 32-bit address, and sometimes processes nowadays are not 32-bit, unless you're playing something like CSGO, which is still 32-bit. But regardless, yes, this is the video. Hope that was good. If not, say I need to work on it better, but I'm out. Peace.